I'm NASA Curriculum Specialist Rochelle Oblak. In this video, you will learn how to assemble the rotation device for the vegetable light curve simulation. The purpose of the simulation is to analyze light reflection on distant asteroids. Students simulate the reflective brightness on a surface to determine shape. This models the same process scientists use to determine the shape of rotating asteroids. I will also show you some low-cost alternatives for the apparatus. You will need 2 potatoes. One potato should be roughly spherical, and the other potato should be elongated. Yams work equally as well. Next, obtain a light source. Clip-on lights work really well. You can also use a light socket or a lamp with the shade removed. If you use a light socket or a lamp, you'll need to make some sort of a shield to focus the light down in one direction. The light source should be a 40-watt bulb. If different student groups are performing the activity, use dark paper behind the apparatus as a backdrop. Next, you will need a small motor that runs at 3 revolutions per minute. I obtained this motor from a popular online shopping website. You may also purchase motors from an online scientific store, catalog, or hobby shop. My motor is actually a motor designed to fasten to a ceiling and to rotate a mirrored disco ball. The motor rotates the potato at a constant, very slow rate. Printed on the back of the rotation device is the rotation rate of 3 RPMs. This motor is best because it also has a hole in the drive shaft. Motors with speeds higher than 3 RPMs are not desirable. If you have a classroom set of motors for other purposes, you could slow down the rotation by coupling the motors with a gearbox. Students should wear safety goggles for this portion of the procedure. First, mount the motor onto a hard surface using a clamp, or you can screw it into a wood platform. Next, use a pair of pliers to cut a paper clip into 2 pieces. You can also use other short segments of stiff wire. Insert the loop of wire into the hole in the drive shaft. Wrap the cut paper clip with tape. Make sure that the tape is tight. Secure a small clamp or zip tie around the tape and drive shaft. The paper clip becomes a mounting pin on which the potato rests. If your motors do not have holes in the drive shaft, you can place sharpened wooden dowels or other stiff wire along the sides, again securing the unit with a zip tie or a small ring clamp. I also recreated this apparatus using a hobby kit I purchased at a clearance sale. The actual assembly is a child's wood craft of a carousel. I assembled only the bottom plate and motor. You can place the potato on top of the rotating surface and get the same effect. If no motors are available, there are other alternatives. Students can turn a wooden dowel. You can use chopsticks or even a camping fork. If students use this method, they must use a timer to determine that their rate is 3 RPM. Finally, you can use a lazy Susan to rotate the potato in the same manner. You can even place clay on the flat surface to lift the potato so that it isn't on the flat plane. In the next video segment, I will show you the student procedures for the experiment.